Why circular functions? Can you tell me? All circular functions. Functions. I'll help you. It's trigonometric functions, sine theta, cos theta, tangent theta. All these are called trigonometric functions. Are they called circular functions? Because consider a unit circle. Can you see the unit circle here?
Yeah.
Consider a unit circle with center at the origin. Okay. If you are rotating it through an angle of theta.
Yeah.
So where it comes over here, right? What coordinates of any point over there? It will be x, right?
X. Yeah.
So anywhere on the x-axis here, what will be the coordinate of this point?
1, 0.
1, 0. Right. Very good. What will be the coordinates of the point on the y-axis?
0, 1.
0, 1. Right. Sine theta is defined as the opposite side by the hypotenuse. Okay? And see the hypotenuse here.
Where?
See, if I draw the triangle over here. Let me draw.
Yeah. It will be 1.
Okay. Yeah, it will be 1, right? Because this is the hypotenuse.
Yeah.
Right? So this will and this will be 1.
Yeah.
Right? So the theta is defined as the opposite side by hypotenuse. So here, what is the opposite side? This is the theta. You can say angle theta, which is the side opposite to this angle theta. What's the opposite to this angle? The angle theta. Opposite this y, right? Opposite side by hypotenuse. What's the hypotenuse here?
1.
1. So you get sine theta is equal to theta. Opposite side hypotenuse over here, it becomes y over 1, which is y, right? And sine theta, that is the adjacent side over hypotenuse. Now, what is the adjacent side here?
1.
Side adjacent to this angle theta. What is the side adjacent to it?
Oh, it's adjacent to x.
Yeah. So x, and the hypotenuse is 1. Right? Over 1, which is x.
Yeah.
Now, the sine theta and cosine theta are all just trigonometric ratios. It's just ratios relating to the opposite side and adjacent side. It's just a relation connecting all these three. Okay? Now, tangent theta and get tan theta. That should be opposite over adjacent side.
Yeah.
Opposite side here.
Opposite side y.
Y. And what is the adjacent side?
X.
X. So here y over x. Right? And already seen that what is y? That is sine. Right?
Yeah.
And what we have seen that to be cosine theta. We can also say tan theta is equal to sine theta over cosine theta. Okay? So the relation connecting tan, sine, and cosine.
Yeah.
Okay. Normally, how do we measure these angles? You got y is equal to sine theta. Here theta is the angle, right? How we measure these angles? See angle degree.
Mhm.
Or we use another measure over here, what is called radians. Yeah. So there are two ways to measure the angles. It is either degrees or radians. Now, how do we find out what degree is equal to what radian? Okay?
Mhm.
Okay, 1 second. We'll see that. Yes. Yeah. For us, the perimeter of a circle
Just one.
this is the unit circle, right?
Yeah. Mhm.
What is the perimeter of a unit circle?
2 pi r.
2, right? Yeah,
Yeah.
that's right. 2 pi perimeter of a circle or circumference is defined as 2 pi r. But here is our what is
It's 1.
1, right? So that means 2 pi times 1. That's 2 pi, right?
2 pi. Yeah.
Yeah. And when the circumference of the circle is 2 pi, that means when it takes a full circle, the perimeter is 2 pi,
2.
right?
Yeah.
And same way, when it's rotated through a full circle, what is the angle?
For what?
Suppose rotate this line segment through a full circle. See, this segment is rotated through a full circle. How many degrees does it cover?
360.
60 degrees. Very good.
Yeah.
Right? So that means 360 degrees must be the same as 2 pi, right?
Yeah. Yeah.
The surface of a circle, that is when it rotates this full circle, get it as 2 pi. When this line segment is rotated through a full circle, how much angle does it cover? 360 degrees. Right?
Yeah.
So 360 degrees is equal to radian. Okay? That clear?
Yeah.
Okay. Corresponding to 360 degrees, you have 2 pi radians.
Yeah.
Okay?
Mhm.
Now, theta will be positive in the first quadrant and second quadrant. Okay? So, have a circle. Here, let me draw a circle. A circle, we can take the coordinate axis, divide it into 4 quadrants, right?
Yeah. Yeah.
Now, quadrant sign will be positive.
Mhm.
In the second quadrant also sign will be positive.
Yeah.
Okay? This is the quadrant, this is the second, this is third, and this is the fourth quadrant. Take an anti-clockwise direction.
Yeah.
Okay?
Mhm.
So, angle, which see, it is equal to sine of theta plus k. That means after each rotation, it covers how many radians? 2 pi.
2 pi.
Right?
Mhm.
Suppose we have an angle over here. Say this is theta. So after one rotation, it's over here, right? So then it is theta plus theta 2 pi, right?
Yeah. Mhm.
So you get the value, isn't it?
Mhm. Yeah.
Rotate it one more time. So what does it become? It becomes theta plus 2 pi, right? But again, you get the same value, right? So that's for all angles of theta plus 2 pi k. You get the same value y. Okay?
Okay.
Where k is an integer. K is integer. So multiples of 2 pi plus theta will give you the same value y for sine theta.
Okay.
Is that
Yes.
okay?
K is negative.
Next, that's what you're going to see the next thing. So theta will be the same. Theta will be equal to sine theta plus 2 pi as well as sine theta minus 2 pi. Okay?
Mm-hmm. Oh, okay, because it's still okay. That makes
Because k is integer. K belongs to z means what? K is an integer. Right? So for both positive as well as negative values of 2 pi,
okay.
you will get equal to sine theta itself.
Mhm.
Okay?
Yes. Yes.
So sine theta plus 2 pi and sine theta minus 2 pi will give you the same value as sine theta. So that's here. You can see in this figure on the right hand side. See here the sine theta. Here. Complete one rotation to the same value. Okay?
Yeah.
Corresponding value will be the same. So with the circle, right? Plus 2 pi it comes back to the same.
Yeah.
So when it is negative 2 pi, you get the same value. Okay?
Mhm. Yeah.
So you must theta plus or minus 2 pi will give you the same value as sine theta. Is that clear?
Yes.
Okay. Now what happens with cos theta? Again the angle theta varies from 360 degrees if it is in degrees, and if in radians it varies from 0 to 2 pi radians, right? Because I told you 360 degrees is equal to 2 pi radians.
Yeah.
Now sin theta is positive in the first and fourth quadrant.
Yeah.
In the first quadrant, all are positive.
Mhm.
All the trigonometric ratios are positive in the first quadrant.
Mhm.
Second is positive, here is positive, and in the fourth, cosine is positive.
Yeah.
So you cosine is positive in the first and fourth.
Mhm.
Okay.
Mhm.
See if we have cosine theta. See it's rotated to an angle theta. The value of cosine theta is, say, this is theta.
Mhm.
Okay.
Yeah.
Now, if suppose is equal to cosine theta plus 2 pi k. See here, this is cosine theta will be this coordinate.
Yeah.
Okay, x coordinate. After rotation, what happens?
It'll be the
It
same
comes
value.
one rotation and it comes here.
Yeah.
The x coordinate will be the same thing, right?
Mhm.
So every time it rotates, is equal to 2 pi radians, right? So for all multiples of 2 pi, theta plus 2 pi will have value. Okay?
Yeah.
That even cosine has a period of 2 pi.
Yeah.
Okay? K is an integer.
Yeah.
So cosine is the same as cosine of theta plus 2 pi, cosine of theta minus 2 pi.
Mhm.
Okay?
Okay.
See that.
Mhm.
Okay, value over here. After one rotation, it becomes theta plus 2 pi. It will come here. Again, 2 rotations, it becomes that. And theta minus 2 pi means, yes, that will also have the same value. Okay? So both sine and cosine has period 2 pi.
Okay.
Now let's see what happens with tan. Tangent is a over x or theta over cosine theta, right?
Yeah.
So it is rotated through 3 degrees, which is equal to 2 pi radians, right? Take the graph of tan.
Yeah.
Positive in the first quadrant and
Yeah.
third.
Yeah.
Tan positive in the first and third quadrant. Okay. Can you hear me?
Yes.
See here, let's consider an angle of theta. Okay.
Oh, okay.
So whatever tan theta you get for this, whatever tan theta you get for this angle, you'll find the same value in the third quadrant also.
Yeah.
Okay? Means periodic have same value in the first and third quadrant, right? So tan has a period of pi. Okay? So that tan theta plus k, where k is any integer. It will value. That is theta is equal to what? Tan theta plus pi and tan theta minus pi. Will be the same. Whatever value you get for tan theta, you get the same value for tan pi plus theta as well as tan pi minus theta. Theta minus pi. Theta minus pi. Yeah. So that means cos has period of 2 pi and has a period of pi.